Hi everyone, welcome to the Data Analysis Skill Series with Jamovi. In this session, we will learn pair t-test. So we will learn the pair t-test under the following outline. First, we will learn the basic concepts of the pair t-test. What are the research questions for which we can apply this pair t-test? The underlying assumptions and the research hypothesis. What are the commands and how to interpret the output, and at the last, how to enter the output in a tabular format and how to write the interpretation. So let's see the example for which this pair t-test would be applicable. So you can measure a continuous variable x on same individual. Like if I want to measure systolic blood pressure of the same individual in summer and then in winter. So it will be the same variable which is measured in the same individual at two different time points. So that's why it is a paired value of the same individual. The second scenario could be you can measure this systolic blood pressure before workout of the same individual and after the workout. So this is again the same variable is being measured at two different conditions. The third example could be if you are measuring the systolic blood pressure of the same person in the right arm and then in the left arm. So this will also be a paired value or a paired observation because you are measuring the systolic blood pressure of the same individual but at two different sites. So here also the pair t-test will be applicable. And then there is another condition, like when you are using two different instruments, one automatic BP machine and the other manual BP machine, and if you want to see whether there is any difference in the systolic blood pressure between these two instruments, then also we can use pair t-test. So what have you seen in all these situations? That the same individual is measured at two different time points under two different conditions for two different sites or by two different instruments. But the observation in all these cases are paired. That's why we can apply pair t-test. So now let's see for what type of research question we can apply pair t-test. So if I want to know whether there is any change in scores in paired observation, or the other research questions could be whether there was a mean difference in BMI value before and after a 6-week exercise program, comparison of pain score measured on VAS scale before and after surgery, and is there any difference in marks obtained in pre-university and university examination of MBBS students. So what have you observed in all these research questions? There is a scale variable in each research question and you want to compare it before and after. So such study design are usually called pre-post study, and the appropriate statistical test for such study design is paired sample t-test, which is also known as pair t-test. So now let's see the underlying assumptions before we can apply this test. So the first assumption is that there should be one dependent variable which should be measured in continuous scale, or that variable should be a scale variable. The second assumption should be that the independent variable that consists of either the two categorical variable or it could be two related groups, or we have discussed about this matched pair, or it could be a matched pair or the paired observation. And the third assumption is that there should be no significant outlier in the differences between the two related groups, and it should be normally distributed. So this third assumption states that we have to check the normality of the difference between the two paired values And again the outlier testing is also done on that difference. So the null hypothesis for this paired t-test is that the population mean difference between the paired values is equal to 0, and the alternate hypothesis is that the population mean difference between the paired values is not equal to 0. Let's learn the paired sample t-test in Jamovi. So this is the question for which I have to apply paired sample t-test. At the time of discharge, we measured patients' hemoglobin levels and provided interpersonal counseling to all patients for dietary modifications. Hemoglobin level was again measured after 3 months, and now we want to know whether there is any change in the mean hemoglobin level of any study subjects after the intervention. So let's see it in Jamovi. So this is Jamovi interface. Click this, open, browse the data. This is my data for paired sample t-test. I have opened this data. So this is the data. Now you have to apply paired sample t-test. So before that, just see these variables, edit the variable. This is the ID. So my main variable is the hemoglobin pre and post. So I'll just check that. The rest you know how to change that. So I'll go to this hemoglobin pre. So this is a continuous variable in this case. So now I'll go ahead again. This is anemia. This is again hemoglobin post. So this is already in continuous variable. So I'll leave it as such. Now come to the data. Click on this analysis. Click on this t-test. Click this paired sample t-test. So before we see this paired sample t-test, we have to check for normality. So move this pre-hemoglobin and post-hemoglobin to this box and click on this QQ plot. Since sample size in this case is more than 50, so I'll go for the QQ plot. Here you can see that the data points are diagonally across this line. So this is normally distributed curve. Since it is normally distributed, so this I will leave this student t-test because this is by default option. But if it is not normally distributed, then I would check this Wilcoxon rank test because this is the non-parametric counterpart of the paired sample t-test. So then you need to click this mean difference and 95% confidence interval of this mean difference because it will tell you the change in the mean hemoglobin level along with its confidence interval. Click on this descriptive because this will give you the mean values before and after, and this is the output which you can see. So if you see the interpretation, this is the T statistics with 192 degree of freedom and this is the p-value. So after interpersonal counseling, there was increase in the mean hemoglobin level which you can see with the minus sign, and you can see the mean value here also. So pre-hemoglobin was 8.58 with standard deviation of 1.59 and post-hemoglobin was 9.28 with a standard deviation of 1.42. So you can see that the mean difference with its 95% confidence interval. Now you have to enter these results in the table. So this is my table. You can go down and see. So this is the mean and standard deviation of pre and post along with the t value, degree of freedom and p value. And this is how we write the interpretation that the difference in mean hemoglobin level was normally distributed as found by the visual inspection of the QQ plot, and there is a significant increment in the mean hemoglobin level after intervention, and this difference of mean hemoglobin was 0.706 along with its 95% confidence interval. So this is how we write the interpretation of paired t-test.